All right, guys, so now we're on to section 2. We're studying our second type of chi-square test, and this is a chi-square test for homogeneity. I know that's kind of a weird word to see. Think of the word homogeneous or homogeneous, right? So homogeneity. This allows us to determine whether a hypothesized distribution is the same for multiple treatments or multiple populations. So this is what we would use if we're examining the distribution of a single variable for multiple populations or treatments. And when we state the null and alternate hypotheses for these, we will be stating that there is or is not a difference in that distribution for each treatment or population, depending on what we're looking at. And so here's the example we're going to go with today. Market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a European restaurant compared 3 randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. So we are checking to see, does the type of music influence the type of entree? And so our null hypothesis for any chi-square test for homogeneity will say there is no difference in the, let's see here, what are we looking at? The type of order or type of entree ordered for each music treatment group. And so what does that mean? That means that whatever percent were in the French music group, that percent will be the same percent that ordered something French, ordered something Italian, and ordered something for the other category. So that these subcategories will be the same regardless of what type of treatment they have. So whether you have no music, French music, or Italian music, you still represent the same percent ordering either French, Italian, or other entrees. Our alternate be the opposite. So instead of there is no difference, we would say there is a difference. All right, so that is how we state our hypotheses for the test of homogeneity. Then we have to find expected counts, and this says in order to perform our chi-square test for homogeneity, we have to do what we did last time. So we have to observe or compare our observed counts with the expected counts. And so remember, here we have a two-way table because we are comparing the type of music, their treatment, with their entree. So we've got more numbers than we did in our goodness of fit test. And the null hypothesis, remember, always says there is no difference. So we are just checking to see what are those portions or proportions represented by each subgroup. And to do that, we find our expected counts using this exact formula. We take the row total times the column total divided by the table total for each entry. So we are going to create a new two-way table. Oops. I'm just going to cut this guy, paste it here, and turn my pen white to white out all these numbers. Our totals will be the same, so we're going to maintain those. But remember, we are going to do row total times column total over table total. Okay, so for this first one, we'll do 99 times 84 divided by 243. And we get 34.22. All right, then we'll do the next one over. So French and French music, 99 times 75 divided by 243 is 30.56. And then this last one, Italian, 99 times 84 divided by 243 is 34.22. Okay, so I'm doing row total times column total over table total for each column. Oops, 2. Now I'll do the next. So 31 times 84, divided by 243. 31 times 75 divided by 243. And then this one actually is the same because our column total is the same. So this would be 10.71. Then 113 times 84 divided by 243 is 39.06. So this will also be that because our row total times column, those are the same. And then the middle one, 113 times 75 divided by 243 will be 34.88. Okay. So that is how we find all of those expected counts. This one is more than the goodness of fit. There's more to it because there's just more categories when you're combining each treatment with each possible outcome. You just result in more categories. All right. Our two conditions, again, I did not clearly change these notes either. The third one is independent. But these stay exactly the same as they were before. So random large counts, independent. And then our chi-square test statistic stays the same. That's the one we use for every chi-square test. So example 3 says we just looked at an example that compared types of music being played with the entree a person orders in a restaurant. Here are the observed and expected count tables. So this is the one we just found. This is the observed values. And so now we're going to find our chi-square test statistic by using our formula for all, unfortunately, yes, 9 combinations. So I'm going to put observed 30 minus expected 34.22 squared over expected. I usually like to organize them in the same way the two-way table's organized so that I know I didn't miss anything. So now 39 minus 30.56 squared over 30.56 and 30 minus 34.22 squared over 34.22. Then my next row would be 11 minus 10.72 squared over 10.72. 1 minus 9.57 squared over 9.57. And 19 minus 10.72 squared over. And then my last one, 43 minus 39.06. 39.06 plus 35 minus 34.88 squared over 34.88 plus 35 minus 39.06. Now you're going to sit tight while I do lots of calculator work. So if you're still copying, take this time to do that. You can hear the lawnmower outside. That is what it is. My husband's mowing the lawn. Sorry. Okay, so far I've got the first 3. Now 11 minus 10.72 squared. second to last, 35 minus 34.88 squared over 34.88. And then 35 minus. So we get a chi-square value here of 14.897002. So there you go. Now we find our p-value exactly like we did last time, except our degrees of freedom are a little different, right? We don't have 9 categories, even though we had 9 numbers. Instead, we're going to do the number of rows minus 1 times the number of columns minus 1, but we do not include the total row or column. So our degrees of freedom here will be equal to, we had 3 treatment groups and 3 possible entrees. So 3 minus 1 times 3 minus 1 will be 4. So now we'll do chi-squared CDF from our test statistic 14.8970 to 1,000, 4 degrees of freedom. It's 0.0049, really, really tiny. All right, so for your practice today, you're gonna do the same thing. I tried to be a little kind to you, and so you only have 2 treatment groups with 2 categories, so you only have to find expected counts for 4 things. So hopefully that makes it a little easier, and that is all you're doing there. Remember, when it says the 2 conditions, hopefully I've fixed that in your notes. It should say 3. Okay, we'll talk to you tomorrow.